I'm Ernestina, working in ESRIC, and we will be together for 1.5 hours. This session for me it's very important because we are going to speak about two important pillars of ESRIC. Actually, the relation that we have with ESA and our partnership. As probably you know already, our partnership is funded with ESA in two specific topics and pillars. The infrastructure and the laboratory support and the commercialization activity. So this is what we will see today. And what it's really nice is that we will have a mix of ESA and ESRIC people speaking together and taking the floor, together with our community. So we will have an introduction of our ESA-ESRIC infrastructure. Then we are going to speak about the commercialization activity, and we will finalize with a panel. Starting with the ESA infrastructure and what's happening next, I'm calling on stage Melchiorre Conti, Space Resources Expert in ESA. Enjoy the talk.
Good morning, everyone. My name is Melchiorre Conti. I'm Space Resource Engineer at ESA. Yeah, you can't see anything past the road, too. I'm a chemical engineer by training, and I have been involved in space resources since 2017-18 and joined the agency in 2019. And basically, I work with ESRIC from its inception. And I have the mandate to include the facilities that ESA is developing into ESRIC, and then look at how we can work with ESRIC through a framework contract to advance a series of topics, of research, of modeling, business, and not just only business. And recently also been involved more with the technology directorate where I now reside. And without further ado, I'm just gonna zip past my slides. We have 9 minutes. So the first project that I started a while back is the ESRU lab, the creation of 3 reactors for molten salt electrolysis. It's been a long time coming, but actually, finally, after a long time, we should have the factory acceptance test at the beginning of June, and soon after, 2 or 3 weeks after, be delivered in ESRIC. These are new cells designed with ESRU in mind, so a break with the past where material construction were not pushed as hard because the byproduct of the molten salt electrolysis was CO and CO2. Now we aim to produce oxygen, so the environment is a lot more aggressive, as you can imagine. So we have had a very intensive campaign in material compatibility with the consortium that is led by SAS, but also our internal colleagues in tech. And we have a very long campaign, about 33 to 35, I don't remember exactly, Emma will know for sure, weeks of experimentation in which we will look at various aspects from preforming anodes, salt quality, and so on and so forth. It is a process that is very flexible. As you can see in the bottom there, you have the leads, which are basically plates that have been perforated and tapped to have enough ports. but with the freedom that we can really remove these leads and adapt it to wherever we need. The big hole that you see in the center is actually a gate valve, because we aim to do long-term experimentation with the salt being kept molten for a very long time and then swap the product in and out to do multiple and sequential tests. After the initial utilization, these will be given on loan to ESRIC to open to the community, and also will be subject to an experimentation campaign through an open call for interest. The other most relevant is the DTVC, which I'm sure Emma will talk to you more about. I just want to show that we went from a drawing to the reality. This is going to be tested for the factory acceptance test in 2 weeks' time, and it will be delivered in June, 16th of June in ESRIC. We plan a commissioning that will go from September to the end of the year, and then in the new year we will have it open to interested parties. And I am glad to say that actually, as you heard from Lunar Outpost yesterday, they already rearing to be using these, and they are not the only ones, so that makes me comfortable that there will be a very interesting pipeline of measurements coming through. And following these, we will probably have a campaign of upgrades to carry out on this facility. The most important and most interesting is that sort of slope AI on the bottom left corner. Actually, is not. It's actually drawings. Those are the dispenser that will be able to diffuse regolith on test item at predetermined speeds. Of course, we have heard from other agencies the work that they're doing on pilot plants. We actually started this in 2023. We had a CDF study on the lunar pilot plant. And in 2024, we launched the terrestrial pilot plant, which will be hosted at ESRIC, a modular open architecture that is designed to be modified as we learn more, and open to the community to bring their technology and be able to plug and play in hours. So we are trying to keep every interface as open as possible. And this was concluded. In January, we had the last review. We are now waiting for the final review. And has been an interesting journey, because we looked at what kind of industries, what kind of users, what kind of utilization could be done of this pilot plant above and beyond whatever the agency wanted to do, to keep it alive, to make it meaningful for the community to use, and to lower the entry barrier to the space resources market, which is a very capital-intensive capital-intensive market. I need to speed up 4 minutes. Not much to say. We are in the procurement of the electrolysis core unit and the regolith handling units. The ITT closes this week. For this reason, I can't say much more. What else? The framework contract. Yes, so ESA has a long-running framework contract, and through these framework contracts, we activate packages of work that the agency deems important in the relation with ESRIC. One of these that has been is negotiated with ESRIC is about the data-centric approach and data management. As you can imagine, between the cells, the DTVC, in the future the pilot plant, the hydrogen plant, we will generate a lot of data. We must make sure that we retain this data, we utilize this data, and we use data to decide our way forward. And not just the data produced by those platform, but also any ancillary data that comes from analysis of the experiments that we do. Where's the funding coming from? What is the purpose, so that you are able, that the user will be able to plan ahead without having to repeat other experiments, making sure that the data they produce is relevant and to a standard that we can use. And these, of course, has implication for the next project that we will launch soon, which is the feasibility study for a digital twin of the pilot plant. You say, but the pilot plant is not there. Exactly, so that's the best moment to start figuring out how you collate data and make it happen in real time, keeping it aligned. We will look at building the fundamental models underpinning each step of the pilot plant, which has, as you can see, pre-processing, salt management, electrolysis, gas management, and we will look at all the factors that influence the science and the engineering behind these steps, making sure that we can build something that is representative, because there is no other analogous to these, and then eventually go to the subsystem level, and once we have that integrated into a fully end-to-end digital twin. Why? Because experimentation is expensive, data capacity and computational capacity are going up. This more than ever is the way forward. Of course, you have to substantiate with experimental data, so what we will also do by the end of the year, we will launch another call for ideas, which will focus on the utilization of the ISROLAB capabilities to look at things like fundamentals of MSC, alloys production, electrode development, new ideas, and of course, as closely related to the pilot plant as we can, creating the basis for the digital model I was talking about. Last but, no, it's not last, but other activities that will come soon, the technology development element, the ITT for an electrolyte recovery and lifetime control is going to be launched soon. On Earth, at the moment, molten salt is dealt with water, because calcium chloride is almost infinitely soluble in water. Of course, it's not something we can do on the moon, and it's not something we're going to do on the pilot plant. So we need to devise methodologies that get away from consumables and ensure that we can reclaim as much of the salt as possible to put it back into the system. And later on this year, I will be working on the inert anodes development for molten salt electrolysis using the GSTP, the General Support Technology Program in tech. So watch this space. Meanwhile, last but not least, the ISRO-DM, the study on the molten salt electrolysis payload. It's just to give you a flavor where we are. We're still, prior to BRR, looking at intense work on the pre-testing before we get to the BRR. I know Mana has a presentation, and probably they are best suited than me to discuss these, but a bit of a flavor of the sort of work that is going on and the time frame of the breadboarding test that will happen later this year. And with that, I think I flushed through enough. So thank you very much for your attention. Any questions?
Very interesting and energetic presentation. Mel, I should admit, let's say we understood that it's coming from inside. You don't need the script and you know everything.
Yeah, don't give the secrets away.
This is show our partnership, right? And where we are going together in the next year. So thank you for this, let's say, review of all the activity. Let's open the question. You have someone? I have some question? Not yet. Okay, so I have one.
I don't know if it's a good sign. There you go. Thank you, Advenit.
Advenit. Oh
so I don't die on stage.
No. Anyway, mine will be safe.
Yes, Advenit Makaya from the European Space Agency. So the facilities that you have shown is ISROLAB, the GBBP. What's the process for people here in the audience to approach you to request some time with those facilities? And is it restricted to Europe or is it open beyond that?
So the microphone level was very low, so I will try and interpret the message. So first question was, what's the time frame, correct? At the moment, sorry, no, to get to use, sorry. First of all, we need to build it. We will, of course, have intense campaigns. We are designing it for running for more than 6 months every year. I can think many ways, most of them related to people bringing the hardware, proposing new equipments to go ancillary to the system. Of course, with the development of extractive technology in Europe, there will be people that might want to test different materials, different anodes, so we will have call for ideas to populate a program of work, so to speak. Of course, meanwhile, we will launch ITTs in a regular cadence. As I said, we did the feasibility study. Now we are procuring the detailed design. The next phase would be the manufacturing. And these are 2 of the 3 units that ESA aims to produce. Of course, if you think of the pilot plant, there is a lot more that needs to go around. So I hope that between ESRIC and the community and the interest of deploying new technology, demonstrating new technology, we will be able to enrich the pilot plant with contribution from the community. What was the other question? I forgot. No, actually no. We are trying to open it to everyone. Of course, as you know, the funding comes from E3P. So we will have a way to interact with member states, a company coming from member states and company not coming from member states. Of course, there is a different regime of charging, but I am sure that in the interest of the community, Space Resources always being a very open forum, we will try to facilitate as much as possible. And that's where the digital twin actually comes in, because, and I'm sure Jerry and if Carl was here, we tried many times to collaborate across the pond. It was always very difficult, so the best way is shown to be a digital interaction.
Yeah, the digital interaction will support the development also of the product.
It goes both ways,
yes.
and it's a good moment to start because, of course, we need to do a lot of fundamental studies to identify the models. And once you get the validation from your experimental work, then you can start scaling up the digital side of it. So computational fluid dynamics, final analysis, and eventually I'm sure AI will play a role. I'm not sure because I'm not an expert, but you throw through kilobytes and megabytes and terabytes of data, and AI has demonstrated to be a lot better than humans to do that.
So there is a long plan.
There is a long road ahead. That's why it's a feasibility study. Then we have a dedicated funding for the development of the digital twin. And there, again, there are plenty of opportunities for people to get in touch with ESRIC and showcase their technology and their knowledge and say, look, we can help in this way. So.
Yes, so to finalize, you already said, but I'm asking my question anyway.
Okay.
How you measure your success beyond the technical performance?
Well, it's not a simple answer, but I guess the best answer is the level of engagement and the level of interest that you can generate through this activity that is really the metric. And we see it with Space Resources. I mean, we went from 200 to more than 450. So I guess we're doing something right.
We had 490 yesterday,
okay.
So I think 500 today.
Oh, nice.
Thank you.
Thank you.
It was a pleasure. So now we saw, thanks to Mel, what is going on in ESA. But this partnership has an interface. And the interface I'm calling on stage now is Emma Cooney. There is the ESA ESRIC Infrastructure Manager, and she will explain to us what's coming soon in ESRIC.
Hi everyone, I'm another proud member of the ESRIC team. So as we've all been discussing, to accelerate the progress needed to develop technologies for ISRU, Europe requires dedicated testing and research platforms that are representative, reliable, and high fidelity for lunar missions and beyond. As part of their ongoing efforts to achieve the next big steps forward, as presented by Mel just now, ESA is very actively delivering to ESRIC strategic facilities to advance research and testing and meet ambitious targets set out in detailed roadmaps and programs. So complementing ESRIC's existing research facilities, the new ESA research and testing infrastructure is coming to ESRIC this year. This includes a new dusty thermal vacuum chamber for testing space components and subsystems in a lunar-relevant environment. We will soon receive the ISRU Lab platform, as Mel presented, due in June and July this year. That's a set of 3 molten salt electrolysis cells for extraction of oxygen and metal products from regolith. And ESA has tendered phase 1, detailed design of the new ground-based pilot plant, which, as Mel said, is providing an end-to-end process for optimizing, de-risking, and providing a reliable long-term operation for oxygen and metals extraction from lunar regolith, using molten salt electrolysis at its core. All of these platforms are available for use by researchers, academics, and industry. Thank you to those already working with us and planning projects with ESRIC and ESA. Our purpose is to advance ISRU together with ESA and our partners through enabling technologies, working in parallel to fast-track progress towards lunar readiness. So firstly, the DTVC, the Dusty Thermal Vacuum Chamber's key specifications are given here. The system is designed with an internal diameter around 2.5 meters and a length around 3.5 meters, with an approximate internal volume of 17 cubic meters. So it's able to accommodate payloads of varying configurations. The staged vacuum system is designed to reach 10 to the minus 6 millibar with regolith simulant in the chamber. Temperatures can range between minus 180 degrees Celsius and plus 160 degrees Celsius, according to lunar day and night extremes. It includes fully automated control and monitoring with multiple sensing of pressure and temperature. It features a dust dispensing system. There is a viewport and camera and lighting systems for remote monitoring and recording inside the chamber during test campaigns. As tests may run over many days in some cases and weeks, this provides relevant visual feedback about the tests and the impact of the environment on the test subject at discrete time points and under specific environmental conditions. For connecting to subsystems and supporting testing and research, there are multiple spare flanges for feed-throughs for power, instruments, control, data, and gas sampling. The new DTVC features a special hatch design to enable future retrofitting, for example, with a solar simulator. The DTVC will be delivered to ESRIC next month by a European consortium led by Spartan Space, with Hox Life support and Luxembourg's own Mana Electric. This slide aims to give you a better picture of a typical testing sequence for a subsystem inside the DTVC. The subsystem is prepared and ready for testing. The test cycle is programmed into the control system. The DTVC is prepared with regolith simulant in the dust dispensers and on the payload tray. These are transferred inside the DTVC. The subsystem is brought into the chamber and set up with all connections. The hatch is closed and the operator initiates the automatic test program. Firstly, the system is depressurized using the 3-stage vacuum system, and then the thermal management system brings the temperature up to the set point. As temperature holds during the dwell time, dust is dispensed automatically. The test cycle continues, the temperature is reduced, and dust can be dispensed again. This repeats until the testing program is complete. In this way, performance of the subsystem and the impact of thermal vacuum with dust deposition can be monitored across several cycles. This allows for critical testing to measure impacts of repeated dust exposure on optical and thermal systems, rotary and sealing systems, dust mitigation and self-cleaning systems, etc. It will be available for all of you, so please engage with us to plan your testing programs. You can see a 1:25 scale model of the DTVC out at ESRIC booth, so please come and visit with us and discuss your test planning needs. In the coming weeks, ESRIC will receive the ESRILab platform, a set of 3 molten salt electrolysis reactors delivered under an ESA contract with a consortium led by Space Application Services. Following installation and commissioning, whereby the system will be validated and characterized, ESRIC will carry out a dedicated work order under the frame contract that Mel was describing. During this program, the 3 cells will be operated concurrently to identify intrinsic and extrinsic process conditions for optimized oxygen production. ESRIC's team looks forward to receiving the ESRILab into our labs and deepening our expertise through this important ESA program. The feasibility study for the ground-based pilot plant has recently been completed, an end-to-end process that is critical to the development of an optimized lunar pilot plant design. The GBPP emphasizes an open architecture, modular design to support investigations and scrutinize performance and evaluate alternative technologies and configurations, reduce complexity, and maximize autonomy and reliability over long-term operation and maintenance. The first phase of the detailed design of the ground-based pilot plant is currently under tender by ESA, for which ESRIC is a mandatory subcontractor, being the future host and operator of the facility. This phase will focus on detailed design of the regolith preparation and molten salt electrolysis reduction units. Thanks to the Luxembourg government and our key stakeholders, led by the Fonds Belval here in Belval in Luxembourg, ESRIC will host and operate the ESA platforms of the DTVC and GBPP in a new building of the Space Campus in the City of Sciences alongside the Luxembourg Institute of Science and Technology in the south of Luxembourg. The building is currently being constructed and will be ready to receive the DTVC in the middle of June this year, with overall completion and handover before the end of the year. For ESRIC, this new research and testing infrastructure will further build on our ISRU facilities and deepen and mature our expertise. We look forward to the exciting year ahead and our cooperation with ESA and all of you, our space resources community. Thank you.
Thank you, Emma. I think it was a very nice presentation. And now it's clear to everyone, I think, what's coming next in ESRIC. Would you like to open the floor for questions, if any? Not yet? Yes, I have one for you. So, we are speaking a lot about, testing inside the DTVC, what we are going to do. Also, Mel said before that we measure through the engagement of the community. So how the community can engage with you to test in the DTVC and in the future GBBP, with you, with us, let's say?
Yeah, so you can contact me directly. We have a direct email contact dedicated just to DTVC test planning, and that is basically the best way to contact us. So you can be in touch with me here at this conference, or via email into the future.
Good. And I know that we get already contacted from a few companies, right, that are willing to test inside the DTVC, that are mainly a race. I want to be the first. I want to be the first. So which one are the use cases that you are investigating with the company today?
Yes, so we have approaching 20 different use cases that have been quite extensively planned out already in terms of testing requirements. Of course, everybody wants to be first, and we're hoping that this facility is available, properly characterized, reliable, and repeatable, and that we can bring this ready for first testing in early 27. We have a number of companies who would like to be first. May end up having to be a lottery, but I think it's going to be based on priority, and that will be something that ESRIC and ESA determine.
Yes, together, right? Because this is a partnership, and
Absolutely.
We operate the DTVC for ESA, so it should be decided together. Okay, I think that's all, and please engage with Emma or to other people from ESRIC if you want to know more about the DTVC, GBBP, and what is going on. Thank you.
Thanks a lot.
Nice. So, as I started before saying that we are going through the partnership that we have with ESA, and this main scope of ESA and ESRIC, that is to building the community, create the partnership, and connect research with the laboratory and with the company. As said yesterday by Bernard during the pitch, that I really like it, we should be the catalyst. And this is what we are trying to do together. So now we are step into the second important pillar, that is the ESA-ESRIC commercialization activity. What we will do, we have a lot of initiative around the commercialization, but what we will do is to let's say, short focus on the operational of the three main initiatives that we have. So the Startup Support Program, the Challenge, and the Accelerator. And then we are going to deep dive as a reality check because now we are 5 years old, so we can call the community, the people that are really using the initiative, and see what they are thinking about and how to move forward. And we will do that together with ESA to understand and to review the ESA vision. So now we will have a talk from Lari Cujko, that is the program lead for the Startup Support Program. Then we will have Advenit Makaya, the advanced engineer, that will speak about the challenge. Then Francesco Liucci, the innovation manager for the accelerator. 5 minutes each, explaining to us their program and what it's about. I'm very happy to call on stage Lari Cujko.
Test. I'm not Ernestina, definitely. So good morning, everyone. Just to introduce myself, I'm Larry, leading the Startup Support Program, which is an incubation program in partnership with ESRIC, with LIST, LSA, ESA, and the Technoport. So in terms of commercialization, what ESRIC is doing, multiple activities. I will not mention all of them or detail all of them. I will focus on the Startup Support Program. We are having the Space Resources Challenge. We have an incubation program for all around the world companies. We have an acceleration program that my friend Francesco will explain after that. And we run all those programs in strong collaboration with ESA, ESRIC, LIST, LSA, and of course the Technoport. So what's our value proposition? Why do we do that? That's very important. We do that to facilitate and to support equipment developers, so to have real testing capabilities, as my colleague has just mentioned, in terms of laboratories. A lot of coming, but this is really the future in the coming months or years. We provide funding opportunities for our national and European ecosystem. This is why we are strongly working with ESA for that. And of course, through the Luxembourg ecosystem, we want to facilitate and support the cluster combination of Luxembourg, supporting really the space resources utilization and development of companies in the national scale. So when did we start the Startup Support Program? It has been announced in AAC in 2021, where the former director, Matthias Link, launched the commercialization program. It was in Dubai. And through all of the years, we have run multiple programs. Here below, you just see a set of companies which are currently part of the ecosystem, 26 projects part of the ecosystem. And we have one starting, which started last week, in fact. How is the program running? I think most of you can find information on the net. You heard me multiple times through the years. So it's a 3 phases program, I would say. We have a first phase where companies remain in remote. They stay in their local home countries. In the second phase, the benefit when they're selected to get a budget, 200,000 euro or dollars, might be quite similar nowadays. And there is a third phase, which is an optional phase, which is mainly focused on commercial development. We do that in partnership, this is very important for us, with the Technoport, our national business and technology incubator, because ESRIC ESA wants to focus on R&D, and we want to step and be sure that all those companies can have the right benefits, the right support in terms of technology to bridge the market. The program is strongly commercial related. Of course, TRL, technology readiness level, this is what the program is trying to do, but we want to focus on the commercial readiness level. That's very important for us. Having a product is great, having a market is better, but how to consolidate the market? This is a real challenge, in fact, because there is no market on the moon, but we focus on dual-use technologies. Some companies have terrestrial application and a space application, and that's where the money is. For now, to give you a small snapshot of the companies who are currently, who secured the 200,000, there are 6 companies. They all had an activity in Luxembourg. Some are ongoing, some change, some have been acquired through M&A activities. Within the value chain, within this very, I would say, linearized value chain, this is where the companies which are part of the ecosystem in Luxembourg are currently providing a support in the ecosystem, providing a technical, a commercial support within the value chain in the local and European markets. For information, that's maybe an important snapshot for a lot of potential applicants. This is where we have seen all along those years where the focus was. We see a strong connection applications within the robotic systems. Slow one in power and energy, might be changing with the future Artemis missions, manufacturing, and prospecting. And I have to say that prospecting and robotics is quite linked. I should combine both to give a 40% in terms of applications. What's important to share also with you, I have talked about the program, but sharing a little bit of success stories of those companies, and most of them already here. So Space Backend, who just recently raised a significant amount of funding, part of the program, part of the SSP, the third cohort. We have a great green tech company, Radiant, where all are present here today, Thomas, Alexandre, and same for Yoav and Dimitri. We have TerraEye. They're not anymore in Luxembourg, but in terms of European market, it's a great success because they have been acquired by a big Abu Dhabi company and provide them a vision for the upcoming years in terms of project and providing support to the European market. Tumi Robotics recently has been selected for the Fit for Start, a national accelerator to support the development of their robotic platform. And to try to conclude, because time is limited, it's a worldwide incubation program. We target all the markets all around the world for the first phase. So every entrepreneur all around the world can be interested by the program. The only point, to get the funding, you need to have an entity in Luxembourg. So the first phase, it's really the de-risking approach. And to announce the selected one, we have currently selected 7 companies from all around the world. We have from US, or from, of course, one from Luxembourg, from Italy, from Austria, through from Asia, first one from India and South Korea, and Japan as well. Most of them are present here. Go to see them. They have tech demos. You can meet some of them here. And to conclude on that and open the room for questions, the program offers a lot of support. Not only cash funding, it's the last one, in fact. It's to build an ecosystem. We provide support in terms of technology, providing expertise from ESA, from ESRIC, from the Luxembourg Institute of Science and Technology, for sure, and multiple set of experts who are working with us from all around the world. Might they come from Corrado School of Mines, from Luxembourg, from Italy, and so on. We provide support for technology development, for business support, because again, having a product, if you cannot commercialize it, it's a little bit more difficult. And based on that, if you have any questions, please do not hesitate. Thank you very much.
Thank you. Lari, we will not have questions, sorry. It will be really 5 minutes, and then people can engage with you. And I will say at the end of the panel that there is the SSP session specific Thursday morning. Thank you. So I will call on Advenit Makaya, the advanced manufacturing engineer, speaking about the challenge.
Thank you very much, Ernestina. So yes, I will tell you a little bit about the new edition of the Space Resources Challenge. So as you probably know, it's the third edition already. The challenge started in 2021. So the challenge is a new way of engaging with the community, the space resources community, to academia, to startups, SMEs, etc. Looking at both identification and maturation of promising technology for space resources utilization, but also commercialization aspect, and at the center of it, of course, innovation. So in 2021, we had the first challenge on excavation, so collecting the resources, mainly regolith here. And in 2024, we had a successful challenge on beneficiation, so how you turn those collected resources into something useful for a process. And the 2026 challenge will be on construction, so a very exciting topic. We chose construction over other processing routes like oxygen extraction because we believe construction will be one of the first, maybe if not the first, application case for space resources utilization in actual lunar infrastructure. So what do we mean by construction? We left the field purposely open. So based on a set of definition we had in the ISECG, the International Space Exploration Coordination Group, ISRU gap assessment report. Construction covers really two types of manufactured products, what we call horizontal construction, landing pads, roads, etc., and vertical construction, so three-dimensional radiation shielding, berms for dust mitigation, construction, etc. So we will leave the field very much open for the participants to propose a constructed product. And as for the previous challenges, the challenge will involve a field test demonstration at the Luna analog facility in Cologne. So you have here an image of the previous challenge. You see the Luna facility. So as Andreas Mogensen said yesterday, it's the closest you can get in Europe to actually walking on the moon. And the challenge will be in 3 steps. So there will first be a call for ideas on the Open Space Innovation Platform, the OSIP platform, which many of you know about, where we will collect proposals from you about concepts for construction, for in-situ construction, what you want to build, etc. And then there will be a first step on actually demonstrating construction at the unit level, making a brick, making a small construction element, and then the full field test at Luna, where you will replicate this unit manufacturing and then assemble it into a constructed product. So we plan to launch the challenge in about a month from now, 6 weeks from now, on the OSIP channel, the Open Space Innovation Platform. And together with our colleagues from ESRIC, Frankie Zarnig is here, the lead from ESRIC, we will promote this challenge in the next few weeks on social media, on LinkedIn, on the ESA websites, etc. So stay tuned and join this exciting adventure with us, because I think construction will have a key place in the future of lunar economy. Thank you, Ernestina.
Thank you, Advenit. So coming soon, stay tuned. And the next one is Francesco Liucci, the Innovation Manager in ESA for the accelerator.
Thank you, Ernestina. Hello, everyone. I'm Francesco Liucci. I'm responsible for the Business in Space Growth Network initiative at ESA. And in the spirit of efficient use of resources, in this case, my poor voice, the presentation today will be short and to the point. I will present you the way in which the BSGN Accelerator for Space Resources work and how it is integrated together with the challenge presented by Advenit and the startup program presented by Lari. If the startup program is more aimed at early stage startups and the challenge provides a very factual challenge for demonstrating capabilities related to space resources, the BSGN Accelerator is aimed at startups and SMEs that have more mature capabilities. We are really looking in the first cohort, in the first phase of this program, at the entire Luna Space Resources value chain. And we opened it with a model of co-funding provided by ESA. We're currently supporting companies across different ESA member states, from Germany, Poland, Canada, Luxembourg, and UK. And as you can see, they work across different use cases and different technology development related to construction, manufacturing, energy, dust mitigation support. The current stage is focused on technology demonstration, which is done on a terrestrial ground. And we unlock funding from ESA up to 50%. So there is a commitment that needs to be shown by companies. They need to be able to have the capabilities to do the intended demonstration and to co-fund the implementation plan, so the actual demonstration that they intend to do in an actual terrestrial environment. What I want to show now is the next phase, because the aim is really to scale. And the next phase is going to be about integration and focus. Advenit mentioned that the next Space Research Challenge is going to be focused on construction, and we want to keep the same focus also for the BSGN accelerator. We want to remain use case focused, and we want to engage the wider community. So the 3 pillars that we aim to enable in the next phase for a higher ambition is first, an industry advisory board, which is a place where we can engage the full community, and in particular terrestrial companies, large terrestrial companies engaged in construction, application, energy, robotics. Because in Europe, we can really scale the capabilities in this environment if we engage with the industrial capacity that we have today, and we fully integrate space and non-space capabilities to move to the next level. Then, the next cohort, we aim to move from the current model in which we support individual companies with different capabilities to try to focus on construction, and possibly aim to select companies with the same project related to construction. This is to be defined in the course of the remaining part of the year, but it could be related to prepare the ground for building lunar infrastructure. It could be related to a lunar landing pad. And the aim would be to issue a call and to select companies with capabilities that can all work in combination and in collaboration as a consortium aiming for the same project. And of course, the biggest ambition is to move from the current terrestrial demonstration stage to a future stage where we prepare for a lunar mission where all these capabilities can be tested in the real environment. If you want to know more, you can engage with me or with ESRIC and Ernestina in particular, with which I work almost on a daily basis, as ESRIC is the main partner in delivering the BSGN accelerator. And stay tuned, because later this year, in September, we will have an important commercialization conference in Copenhagen, 1st and 2nd of September. And it will be a great occasion to have you there to engage with these topics. Thank you for your attention.
Thank you, Francesco. Very nice. I think that we have revealed a lot of things, that mainly we will focus on construction through the challenge and the accelerator, and that there will be a conference in September as well, and then we are creating an advisory board. So a lot of information are coming now. As said, the SSP will have a session Tuesday morning on the parallel room, so there will be a lot of information about the startup support program. And there is also tomorrow morning a workshop. Related to BSGN, indeed, we will have a panel Thursday afternoon in this room. So now, let's go further. We have discovered the program that we have, and now I'm sincerely very glad to call on stage the company that participated in the last editions to our initiatives, together with the ESA Vision. So I'm calling on stage Bernard Uffenbach, that is the commercial, the innovation lead in ESA. Mainly is our, let's say, mentor and main interest. Thank you, Bernard. Then Alexandre Meuris, that is the CTO of Radiant. We have a long history with him, and I will explain to you later on. Thank you, Alexander. Luca Segliento of Mana, the Chief Operating Officer and co-founder, as Alexander as well, for his company. And then Paul Zabel of DLR, Group Leader in ISRU Development. I'm just asking to the, do we have another microphone over there, or you have only one? Okay, great. Thank you. I'm very glad to have you here. I would like to make an introduction, because we asked between us, between me and Catherine, how to explain to everyone our initiative and what we are going to do. And we said the best is that you speak for us. So I would like to start with Alexander, because this is an interesting journey. Actually, Alexander worked in ESA under Bernard, just to explain to you that the community is working. And then at a certain point decided to say bye-bye, but not because, for a different challenge, right? So he decided to open a company and be the founder of, let's say, a few months ago, Neamine, that now is Radiant. And he applied for the startup support program. So what I want to know from you, and what is interesting, is that he knew the initiative from inside, and he believed because he applied. So Alexander, please, can you explain to us your journey?
Yes, thank you, Ernestina. So yes, after 4 years working at ESA with Bernard's teams, I needed some space, or at least doing space differently. So that's why I looked into, yes, maybe more risky approach, and that's why I got really attracted by the startup environment. And that's actually at the Space Resources Week that I met my co-founder, Thomas, and together we share the same vision. We just had now to find a way to shape it, and that's where the SSP, the Startup Support Program from ESRIC, was really instrumental for that, to really, get us to better understand what we need for securing a market on the short term, and at the same time developing let's say, a ISRU vision. So, now we have a company that is running. We've managed to secure funding, so yeah.
What do you do? Because we didn't say.
Yes. So what we do, we realize that on the ISRU side there is some power constraint, and at the same time on Earth we need to decarbonize the Earth. So we are developing carbon-free energy based on solar concentration that is used today to produce megawatts type of power for industry, and tomorrow for powering ISRU systems.
Good. Did I understand well that you met your co-founder during Space Resource Week?
Yes, exactly.
Okay.
Yes. 3 years
so
ago.
You see, community working.
Yes.
And Bernard, so now the question is for you, right? What do you think about when let's say a few years ago, I think 4 or 5 years ago, you thought about the commercialization, ESRIC commercialization initiative. Did you expect someone from your team get out and meeting another co-founder at the Space Resource Week and then apply for the startups program? Which one was your vision?
I didn't expect it, but it was very useful to see that this is happening, and I would encourage everybody to try at a young age to create a startup. But I think we've just seen the 3 presentations, and I think each of the tools in itself is quite effective today. I think we have created a nice scheme to engage academia through the challenge, and we get a lot of engagement, and the teams are really excited and love the field test in Luna. It's really an incredible experience. The startup program that helps young teams to form startups is, I think, also working in itself. And the accelerator helps to advance technologies up to tier 4, 5, and also further, to some extent, mature the company. So I think that works quite well. And so far that we help to shape this innovation ecosystem, which is growing. There are more and more startups. There are things which are not going so well yet, because once the acceleration is done, there's not much to follow up. And we see here a good example with these companies, and the companies are challenged to find other ways to sell their services and products. They need to diversify to the terrestrial sector. So I think we are good in building innovation system. We have not yet managed to scale venture. So that's the next challenge we need to tackle.
Thank you. Yes, the Thursday afternoon, I think, will be dedicated to scale up. So now I'm passing by to Luca. That is a Luxembourgish company. And you know, what I know from Luca is that a lot of time when we speak about a company in Israel, we mention MANA around Europe, right? Because this is what you do. What is interesting for me is that you applied for different initiatives and you won them. You get it? You get it. So what I would like to ask you is, first of all, to explain what you do in your company, but also how these initiative tools are fitting your roadmap. Because, as explained by Bernard, we have different type of initiative for different technology readiness.
Yes, so MANA started in Luxembourg in 2018, so now it's 8 years that we are in the field of ISRU, and we started with this very ambitious vision of developing power infrastructures on the moon. Francesco showed in the previous slide, our goal is to produce solar panels on the moon, which is something that we actually achieved a first demonstration like 2 years ago. But after that, we realized that the timing clearly is not yet there. Before building such a large infrastructure, we have to make a few more steps. And that was also the push for us to narrow down our scope with still that idea in mind of what we want to do in the future, but now to focus on what are the most important, in our opinion, steps that needs to be fulfilled in order to have this lunar supply chain established. So we are focusing essentially on beneficiation, resource extraction, and purification. And that's also how then we develop this strategy where the tools that ESA and ESRIC have put in place have been very functional to what we want to achieve. In particular, as you said, we applied for few of the tools that have been presented previously, particularly the Space Resource Challenge, the second edition of the Space Resource Challenge, which was a good opportunity for us to first test our technology in a real lunar environment or simulated lunar environment to reinforce collaboration with other companies that are working in the same field, particularly the challenge for those of you that didn't know. The scope was put together excavation, mobility unit, and beneficiation in the same, let's say, consortium. And since some of these things are not in our know-how, we decided also to go with companies that could provide us this expertise. So it was also a way to foster collaboration. And for instance, we also are in the Space Resource Accelerator, which is a way for us to continue developing technologies more oriented on the moon with this goal of having a first lunar demonstration of these building blocks we are working on. So beneficiation, resource extraction, and purification, all combined in one unique payload that could hopefully be tested soon on the moon and give us also, let's say, also more credibility for the work that we have done in the last years.
Thank you. And yeah, speaking about the challenge, we should go through Paul. That is the group leader for ESRU, and I can say to you that they are doing so many things in space resources development. I was astonished when I saw all the activity that is going on in his department, and is the winner of the challenge. But what is important here, not only that is the winner, is this is a research center. So that's to show that our initiative are also open to the research part somehow. So Paul, can you explain to us what you do and why you decided to apply for the challenge, for example?
Okay, yeah. So in my team, we work on two big topics. One is lunar water extraction, and the next one is regolith beneficiation. And therefore, the last challenge was, for us, the perfect fit to further develop our technologies and our experiments that we already had in our laboratory, to demonstrate them in the lunar facility in an operational environment. And we teamed up with a robotics institute, which is literally 200 meters from our own institute. So it was very convenient for us to work together. We just moved the hardware with hand-pulled carts between the institutes as a little anecdote. And you can see the rovers at the tech demo booth. So you can see the rover with the excavation mechanism. You cannot see our system, it's not here. But it was a great opportunity in the challenge to bring together the robotics part and the beneficiation part to demonstrate the first steps of a process chain which works with regolith, which then eventually at some point goes into construction or oxygen and metal extraction.
When is the tech demo? Tomorrow, right? Just to remember.
I think so, but I think the rover can be
Yes,
visited
exactly.
any time. The
I will
colleagues are
check
here.
later on. It should be tomorrow, lunchtime or break in the afternoon. I didn't recall very well. But yeah, that's super interesting to see, what you did during the challenge that is here. Yes, so now, Alexander, we know now how you arrived to the SSP, but what's happened in between? So you were in the program that Lari explained before. You opened the company in Luxembourg because in reality you are a French company in Paris. And then what's happened? I just want to know more because I know that something important happened as showed also by Lari in the last weeks, I would say.
Thanks, Larry, for the shout out. Yes, so the last month we managed to get VC funding, which is always the target for our startup, of course. That show off that there is a market for the technology we propose, that it shows some confidence that from investors, which is always good to take, and that we don't only rely on public funding. So yes, we managed to secure like €2 million, which really was key for us now to grow a team. We went from 3 people last year to now 8 people in the team. So now it starts to look like a company. And you are right now, we are only based in Paris, and we have offices in Luxembourg, and for us that's really the next step. So now that we have a solid base in Paris for developing our terrestrial system, now the idea is to expand it in Luxembourg and expand the team in Luxembourg, of course, with maybe LuxImpulse or other mechanism that we have in here to really expand the team in Esch-sur-Alzette and work on ISRU.
Nice. Luca, so what you will say to Alexander? Because it's next step for him is to expand in Luxembourg. And I suppose you should hire people, you should deal with administration. Probably you would like to ask the support of Luxembourg Space Agency. And probably you would like to be connected with the community. And here we have the expert of Luxembourg. Because you are not in Esch, but you are in Fürth, 5 kilometers distant.
Well, Luxembourg is a small country, so it doesn't matter the distance so much. Well, I don't think Alexander needs many recommendations on my side. He's very much experienced so far. But it's true that Luxembourg has grown in the last years a very interesting environment. So I moved to Luxembourg 8 years ago. We have been one of the first companies that benefited from the Space Resource Initiative in Luxembourg, which is, yesterday Matthias Link mentioned that was very proud of the initiative because it's where everything started. There are many positive reasons for working in Luxembourg, not just because it's the country of the space resources, but also because certain aspects in entrepreneurship are very, I would say, much simpler than in other countries. Here, for sure, you have the possibility to directly connect with the Luxembourg Space Agency. They have been very supportive to MANA from the beginning, and they also helped us in growing the company, not just from, let's say, technical standpoint with the support with the LuxImpulse program, but also in advising us on what's the best things to do for making the company successful. And today, after 8 years, we also rely a lot on their support. LuxImpulse is clearly a very good program, and now it's also, after many years, quite advanced, and I would suggest maybe to try to get in touch with LSA for that. And what more important, also thanks to ESRIC, when we started, basically we were just a few companies. Some of them, unfortunately, are no more here in Luxembourg. But now there is a large community here and some platforms that could be used for really progress. And what is important is that there is people from which you can learn what mistakes you should not do. We are probably one of those. We paid with our skin in the game. But there are also other opportunities to work together, as I said before, that could simplify and make your work more successful. So in that sense, it's not just collaboration between projects, maybe also the use of facilities that are already existing, because there are companies that worked in the years for setting up very nice facilities, or also create connections with the government or with the ESA that, of course, you have very good relationships. But yeah, it's also a suggestion for the people that are starting today, that have been selected for the incubator, that don't stay closed within your four walls, but try to talk with as many people as possible, because there are many opportunities that can just come out simply having a chat with this guy, or that guy. Space Resources Week for us is also a very good opportunity to meet people and then connect the dots and find a way to make new projects together. So it's, in principle, a small piece of advice that I would give you, but I'm pretty sure that you already know what to do.
And in terms of finding people, like recruiting engineers, is it because in Paris we have a chance to have like a huge pool of engineers, but I've heard that maybe in Luxembourg it's a bit tough. So I wanted to.
So talents are not missing in Luxembourg. The problem is more to move people from outside Luxembourg to Luxembourg for reasons that are not related to, I would say, the industry, the salaries, and so on. It's more because there's a structural problem in Luxembourg with housing and cost of life. But in principle, if you manage to move people from outside Luxembourg to Luxembourg, generally these people are very motivated, and also people that will contribute a lot to your project. So that's why, yes, it's a complicated process, but generally the people that you manage to convince to move to Luxembourg are also the people that are more motivated to do well, and they are mostly also motivated by the topic, by working in space. So it can be difficult, but it can pay back on the longer term.
Thanks.
Thank you, Luca. I just would like to make a bit of publicity, because ESRIC is a service provider of MANA for test capability. So that's very, very nice what you say. Thank you. So to get engaged with the community as well to make tests, maybe they can come also to you, because you have some other testing capability and so on. Before to leave the word to Bernard, I would like to ask Paul, what's next you will do now with your tech demo and the challenge activity? Because you know there is a certain vision, a roadmap, what you would like to do, right?
Yeah, so now, thanks to the prize money from the challenge, we can faster develop our system to the next stage. And what we plan to do in this, so to say, in the next step is that we improve the reliability of the systems, also to improve the autonomy of the systems. During the challenge, we controlled the system remotely, but we want to employ some more autonomy to the system. And the goal would be to be again in a lunar facility early next year to more or less repeat the challenge from last year, but with a bit relaxed constraints, especially in terms of time, because during the challenge we only had 2.5 hours of operational time, which was, for us it was enough, but it's better to have 20 hours of operational time, for sure. So, and what we also want to take into account, especially for developing the beneficiation system, is to already look ahead on which landers it could fit, to see if we have to rescale the unit, because right now our beneficiation system it's just a very big box. It's very long because of the process that we used, and it's definitely not fit for a lunar lander at the moment. But we want to use the challenge money to make this step, to scale it in a way that it could fit on a lander. And also we want to see that we will want to apply for the next lunar parabolic flight to also test the system under lunar gravity, because this is something that we cannot do in a lunar facility, of course, but to do both next round of development, testing it in a lunar facility and testing more or less the same system in a parabolic flight, would be a good combination. Although I'm aware getting on a parabolic flight is very competitive in its own way. So I think we have to write a very competitive and compelling proposal for that.
Bernard.
Actually, we have the same plan, so
Yes,
maybe we should talk together about that.
That's what I want to say to Bernard. So what about this community? How it's working for you? There is opportunity. And speaking with Bolled, also with Luca, both of them, they would you like to have a flight opportunity anyway. So far, I think we are working well together, right? Which one is your thought on that, looking at the company here?
No, I think in a broader sense, after running these tools now for a couple of years, and we did have some discussion, Ernestina, last year, we were thinking about how can we improve it for the community? How can we make it more effective, get more out of the same by better coordinating these tools? And I think we've taken some decisions, which I think quite important. Firstly, we said in future we focus strictly on ISRU applications. We want to see the endpoint, because in the end, if we don't develop applications, we will never see the rise of space resources. You heard already earlier that we think we should focus on early use cases, and the early use cases are likely construction. So we said for the foreseeable future, the next 3 years, the challenge, the accelerator, the incubator will be thematically focused on construction. So that allows, in principle, teams to go through the whole process if they're successful and get closer to potentially delivering an end-to-end service. So then also, that was mentioned by Francesco, if you want to deliver an end-to-end service, probably as a company you need partnership. And so we want to see how we can help the building of partnerships. Maybe even during the acceleration phase, that there is a consortia which can in future offer an end-to-end service. That's another thing we would like to do. We definitely open all the research facilities, which were presented by Emma earlier, and we are promising to make it as simple as possible. I think there should be no charge for startups, no charge for academic teams. We need to find a way to make that possible without too much bureaucracy. I think that's a very strong step moving forward. And then I think we are trying to do something new. It was also mentioned. I think our intent is to establish a strategic advisory committee. And what we need in this committee are not service providers. We need potential future customers, because nobody has a customer today. So we have to really think deep about who is maybe the first customer of these services. And I don't think necessarily that space agencies will be necessarily the customer. There are other operators around in the world which may benefit from embedding ISU solution in their offer to the agency. So hence we will establish an international advisory committee where we include some customers which help us to define these tools to create services and products they have maybe an interest in using. So in other words, we try to bring us closer to the market. And yet another element in this consideration is we see that companies like the one we heard, they need to sell to terrestrial markets to survive. I think we should make that an incremental part of our evaluation process. We need to ask each company to show us a commercialization plan towards terrestrial markets. But we should do more. We should create a community of terrestrial partners and engage them early to make this partnership building and selling into this market as early as possible. So these are some of the near-term actions for the next 3 years we're trying to tackle. Actually, we have in a few hours a kick-off meeting with Ernestina to talk about specifics how we will make that happen. That doesn't yet solve the scale-up issue, but it will make the ride from academia to TL5 partnership building hopefully even more smooth.
Thank you, Bernard. I think that everyone was touched by your summary, at least me, because you explained it very well, our system working together and the vision that we have and where we are going. And I think also some revelation, right? So the ESRU application, the construction, and so on. We have other questions for you, but as the conversation, I think it's very interesting. I would like to know if maybe there is some question coming from the public. Someone has a question? No one? No. Okay. So I'm continuing with my tour. And now I have the same question for all the three companies here. That is, let's say, you can start. Alexander, let's start with Alexander. So, you know, there will be has happened for you, people here in the room, and there was just a lady yesterday asking, you know, a chemical engineer that she wants to start and work in the ESRU ecosystem and so on. So which advice you will give to someone that will come inside the community and so on?
Well, go ahead and give it a go. I mean, I think it's important just to sometimes take some risk and really, try. And your first idea will very likely not be the one that will make your company or startup successful, and that's just the normal process. So pivoting is normal, and you should not be afraid of it. It's just part of the process, and I think there is a chance in Luxembourg, but also mainly in Europe, to really have an ecosystem that really supports startups, to just have the time and the resources to try. So go ahead, don't be scared, and just try.
Do it. Let's make it, as we say in Luxembourg. Paul.
Yeah, I mean, I'm not in a company, I'm in a research organization, so I will speak a bit about research in ISRU. I think the most interesting thing of ISRU is that it is multidisciplinary. You can have a very different background. You don't need to be a space engineer. I think, in fact, it's beneficial to not be a space engineer for most ISRU developments and research, because you need specific knowledge on processes, or on electronics, and so on, or on mining. And you can do this at companies, but you can also, if you're more interested into research, look around. There's many universities who are involved, research organizations that are involved, and then naturally, the research also partners with industry. So if you start in research, it doesn't mean you end up in industry forever. You can change. I mean, it didn't happen to me. I'm 15 years in the same organization, so, but I'm happy. But I think it's, you have multiple ways in ISRU from a topic point of view, but also from career paths. You can start as a researcher, then you can found a startup, or you directly go into industry. I think most importantly, I would say, be it events like the Space Resources Week, connect to people, see what interests you and where the interests align, and then talk to people and see who can offer you a position.
Thank you. And indeed, you are here because you are a researcher, and we would like to match research and commercialization. Luca.
Well, I feel particularly inspired by this question. I have advices for everyone, but for let's say the young entrepreneurs that want to start now a new business, as Alexander said, take the risk, but also be flexible and be resilient, because things can get more complicated, especially when technology is involved. Startup's life is a roller coaster of emotions, and sometimes you can be frustrated, you can be demotivated, and you need to really have a nice team backing you that motivates you to continue in what you are doing and see positive things, even if everything is dark in that moment. For agencies and for maybe also ESRIC, keep holding a bold vision for the future. ISRU is a very niche domain, and we are lucky that there is people in the agencies and the governments that are supporting this vision, but it's a system that requires to be continuously fed. And we are building as community a system that is slowly growing, because when we started with Mana, there was almost nobody, just people that believed in us. And today, there are accelerators, there are incubators. There is a push for commercialization, but there is also the need for, let's say, I'm thinking about, private capital that wants to invest more and be more brave and not just like try to support what happens after, because clearly, as Bernard said, ESA cannot be the only customer. ESA cannot be the only one putting money. We have to find a way also to make sure that companies like Mana and many others in this room are able to walk with their own legs without having this emotional roller coaster every day, because maybe you have to find the right balance between all the needs. So I think it's very general advice, but is really, I'm really putting fingers in the past 8 years of Mana, where we really had to fight for our life. So yeah.
The pioneer of everything. Yeah, we didn't touch the fact, but because we cannot speak about everything, the fact that both Radiant and Mana are also in the terrestrial application, and this is supporting, let's say, the space advancement. So, 6 minutes. Before to give the word to Bernard, I just want to say that you know, I was thinking something this morning, because last year, I came to Paris for an ESA investor dinner with Mana and Radiant. It's really a case that both of you are here, because there were also other company from the Startup Support Program and other company from the Accelerator. Volta as well was with us. But, you know, I remember 2 things from this ESA investors dinner. And also Gianluigi Baldesi from ESA said to me that the company from our ecosystem, they were well prepared. What that means? That the pitch was really well done, the business case was really well prepared, they were, let's say, they were feeling comfortable to speak with investors. So now, you know, he said to me, yeah, our company, they are mature. When we choose good, Bernard, right? Exactly. And then there is another thing that we do. It's not, okay, you do the big and then bye-bye. We stay with the company, also after. Lunar Outpost is an example, stay with us. Space Backend, it's finishing the phase 2, but it's still with us and in our community. So we are bringing the company together, we are together with the company, and we are moving forward. And another thing that I would like to underline is that our initiatives, what you said, Bernard, the commercialization, the application, how we work together. When I'm going outside of Luxembourg for meetings, visit, mission, and so on, everyone, it's quite interesting to know how you do, what do you do, and there are also, now I'm seeing that there are a lot of initiatives, not only me, you saw as well, right? Initiative around the world that are trying to take it ESRIC ESA commercialization as example and customize for their environment. So that's quite interesting and nice, right? 4 minutes, Bernard. I would like to give the word to you to close our panel, because you know, you are the one that from the beginning were with us and saw the vision 5 years ago.
So first, it's nice to sit here with 3 leaders of success stories from different perspectives. But that makes you also feeling responsible to make sure that our initiative is successful. And I think somehow we own it to the community, which is growing, to give them a future. And future means commercial viability in the long term. And that's still a huge challenge, because there is no market today. So rather than closing the panel, I would like to look forward. And I think Ernestina, ESRIC, and ESA, we have kind of a responsibility to think beyond what we're doing today. Again, we are quite good in creating innovation system. Now we need to scale. And I think there are some concrete scenarios we can explore with support of all the ESA member states, of course. I think the first thing we could think about is how can ESA and ESRIC create a demand signal by really helping companies to scale from tier 5 to 9, helping them to demonstrate something in situ on the lunar surface, and enabling a service transaction, buying something. That has happened before, I think it doesn't require a tremendous amount of funding. It can also be supported through in-kind contributions by giving a opportunity to land a payload on the moon. I think we need to explore that. That's a big discussion. It involves member states, different levels, but I think we should really work on this because for me that's the next step, how we can trigger scaling. And if we manage to do that, I think it unlocks another tool. Wouldn't it be nice if we can create a deep tech investment fund with a 3-digit million figure where space resources is on the agenda? I think if we manage to create this demand signal, I think it might be also easier to create such a fund. So I would like to challenge us to work on these next 2 topics in the next year and report in 2027 whether we made any progress on these 2 topics. And that's my conclusion. Thank you.
Thank you. We have a challenge now for next year. And I should admit that in the room here we have a space fund actually that just contacted me and to see what we can do together. And so let's see if for next year we will be able to move forward on that topic specific. Yeah, thank you, Bernard. I think there was a quite a nice conversation. I would just to pick the word of the CEO of LIST of yesterday, Olivier Guillaume, that said the best has to come. So this is what you say, right? So now we are going to TRL 9 because we are still 6, 7. Good. I think it's time for the lunch. Thank you so much to everyone. We had an incredible conversation. Yes. One question. Okay. I don't know if we have time. 1 minute. 1 minute.
Hi, my name is Sujit Pal. I'm with Public Access. I had a quick question for you. With regards to startups, how do you see them positioning to get venture capital, primarily because the VCs have a 10-year horizon on the return on their funds? And some of these projects currently don't have viable commercialization timelines in terms of generating actual revenue. So if you can give a few words of advice, that'll be great.
So the answer is terrestrial market. You need to have a terrestrial market that will buy your product before ISRU kicks in. So for us, we do power installation at a megawatt scale for industry to replace their gas consumption by carbon-free heat, and that's for our case. But you need a terrestrial market. You need a terrestrial customer that will buy your product in the next 10 years, as you said. Otherwise, VC won't join in. Yes.
Yeah, for Mana, it's more or less the same as for Radiant. We started with this idea that the dual use was the holy grail because space and terrestrial developed under the same umbrella of technology could have been something that maybe the investor could like. The reality is that we had to face the reality that investors are looking for very simple cases where there is already a commercial path on the horizon. And that's why we also decided, the same as Alexander did, to split the terrestrial case from the space case. The terrestrial case now is very investable, it's commercial. They are using essentially the same IP that we have developed for space. Space One, we are looking for, let's say, some visionary and brave investors. But what I would say is that a month ago, we had the Artemis mission that was very successful, and I hope that this can also make potential investors more confident that this market is actually closer than what they expected. A year ago or 2 years ago, we were talking about, who knows if it happens. Now it actually is actually happening, so maybe this could also be the flywheel for some early investors to start jumping on this train that is gonna get there anyways. It's just a matter if we have the right resources to make it happen. And one of the mottos of Luxembourg is, let's make it happen. I don't see why we should not think about that now.
Thank you, Luca. I should close the session as it's lunchtime and probably everyone wants to go to eat. And now we will have a tech demo where 2 companies from the startup support program and 1 from the accelerator work together. So it's just an example of how our ecosystem is working. Thank you.